Hello, Algebra 2 students. This is Mrs. Bird. I'm coming to you with actually, I just saw a typo, Project 1 uh, tutorial, specifically the part of Project 1 that is being presented to you in Lesson 2. So there's 6 questions presented to you in Lesson 2, and I'm going to walk through each of those right now. So question number 1 is about Princess Polly. She's doing a product, means that she's multiplying two different complex numbers, 5 plus 3i, and then we have the 6 minus 4i. Sorry about that, it keeps on doing that. And she's saying that the product, the answer, as 12 plus 0i, and she is using that complex form of a plus bi. So she's using the correct form, but we were asked to tell Princess Polly if she is correct. So essentially we're asked to check, did she multiply these two correctly? And you'll see from the presented solutions, if she did not, identify what the problem is. So to find if she's correct, we actually need to do the product of these ourselves. So I'm going to do that over here on my split screen on the right. Okay, so I see essentially two binomials. They're complex numbers, but they're presented or handled the exact same way as binomials. So I am going to distribute, some of you guys maybe use the acronym of FOIL here. So this 5 needs to be distributed to the 6, as well as that second term of negative 4i. And when I do that, I will get, let's see, 30 minus 20i. And then I need to distribute that 3i to those two terms as well, which gets me a positive 18i minus 12. And then here's the only thing that could be a little tricky is I times I turns into an I squared. Okay, so that's not too bad, but we now just need to start simplifying. I do see some like terms here in terms of just i's. So I'll go ahead and simplify that. Let's see, that would be minus 2i. And then I've left this second piece right here because we need to recall what the definition of I is. So I is actually equal to the square root of a negative 1. It is the definition of our imaginary number. But I don't have just an I here, I have an I squared. So imagine squaring both sides of that. And how would that simplify? Well, I squared is I squared. But here we have inverses. Square root and a square are inverses. So I get a negative 1. So this is something worthwhile to committing to your memory. I squared is actually equal to a negative 1, which means that I can replace that I squared with a negative 1. And now I'm just seeing a little bit more simplification here. Negative 12 times a negative 1 becomes a positive 12. And now I see just real numbers there. So 30 plus 12 is 42 minus 2i. So that is a different solution than what Princess Polly came up with. Is that being weird? It won't let me write on it. So is she correct? No. Where did she go wrong? Well, you have to analyze what those possible solutions are and see what she did. My guess is that she probably added them. Yeah, so here's our correct answer for that number 1. Okay, so let's move on to question number 2, which is giving us a proof of Princess Polly's work. So she has kind of a complex solution here. We have one complex number multiplying with another complex number, but then it's going to be subtracting with the product of another two complex numbers. So a lot of different operations here. I got multiplication of two complex numbers, actually multiplication in 2 spots, as well as subtraction. So first thing that I noticed is that I'm going to be making sure, did Princess Polly follow the order of operations as she was doing this? So let's just read through her work, which is being presented in not a table, what is this called? A proof. Oh, yeah. So here is our original problem that was given to us. So that is the reasoning. Okay, well, what did she do in this first step? She recognized that 3 minus 5i was multiplying in both sides, if you will, of this expression. It's a 3 minus 5i here and a 3 minus 5i here. So she recognized that as a common factor, and she just factored that out. So to do that, she would essentially, I like the term of like pulling it out into the front. Why won't it let me write? That is so funky. It won't let me write. So that 3 minus 5i, she needs to pull it out in front there, but did she do it correctly? So 3 minus 5i, if she pulled that out into the front, she would still be needing to multiply with this 9 plus 2i part. And then we still have that subtraction of that second part of 9 plus I. Now I'm showing the brackets here because these brackets are showing that this 3 minus 5i, it was multiplying with both of those two complex numbers, which is true is what we see over here. It's multiplying with both those terms. So I can see that distributing. Now, she didn't use those brackets. Not necessary to use them, but again, I like to see that. So I think that I'm seeing that she simplified this just a little bit. So let's see if I simplify mine and I get the same thing. This minus, I always forget. If you're like me, you forget to distribute that negative because it really is a -1. So that means that I would still have 3 minus 5i multiplying with 9 plus 2i minus 9 minus I. I automatically see a discrepancy she has that plus I right here. So she forgot this step of distributing. So the question asks, did she do her proof correct? No, she did not. She did make a mistake in that second part in question number 2, or statement number 2. She did not simplify these two correctly as I had shown over here. Which unfortunately, as you know, in algebra, if you mess up in the second step, it messes up the rest of it. So she got the rest of her proof incorrect. So that was question number 2. Yeah, so she made that mistake in the statement 2. So this is that correct response that you're looking for. Okay, question number 3. Princess Polly says that she has a product of one complex number with a second complex number, and she got this answer. Is she true? Is the statement true regarding her product? In other words, did she do it correctly? Well, to know if she did it correctly, we first have to do it correctly ourselves. So that is not supposed to be a 9. It is meant to be a 7 over 4. Where did my 9 come from? Oh, that's where 9/4 I. So that's the first complex number. Multiplying with the second complex number. Oh, wait. Wow, you guys, I just recognized something. I'm recognizing that these two are actually, they're called conjugate pairs. The only difference in them being the plus and the minus. But we also can call those a difference of squares. If you remember, a difference of squares in polynomials is when I have two terms multiplying with another binomial, the only difference being a positive and a negative. So if you recall, there's a little formula that says whatever that a term is, I square it, and then I subtract that with whatever the b term is and square it. Now you can FOIL this out. I think if I use this little formula though, it could just be faster, so I'm gonna undo that. However, if you didn't recognize that formula, no biggie, just go ahead and use that distributive just like I did in number 1. Okay. But using that difference of squares, I can recognize a to be 7/4 x. Don't forget your x term. And then the b term is that 9/4 I. So according to that little formula, I have the a, 7/4 x squared. I like to show the parentheses because that way that squared means that all of a needs to be squared, and I subtract with all of b squared there. Okay, so now I just need to square things. 7 squared is 49 over 16 x squared minus 81 over 16, and then we get an I squared. Cool. Remember, commit to memory that I squared is actually equal to a -1. So using my substitution rule, I can replace I squared with that -1 to get 49 over 16 x squared plus 81/16. So, did she do it correctly? I will leave you to be the judge. But yeah, her answer matches my answer. There we go. So that is question number 3. Okay, moving on to question number 4. Princess Polly claims that the equation 3x minus 4i times 7x minus I times 3x plus 4i equals 0. She's saying it has 3 roots. Now, I know, quick vocabulary lesson, roots are the exact same thing as solutions. There's my abbreviation for solutions, are the same thing as zeros, are the same thing as x-intercepts. So any one of those words could be used interchangeably for that word of roots. So she says it has 3 roots, 1 real root and one complex root, a meaning 1 complex root with a multiplicity of 2. Which statement? Okay, so match the statement. I'm not showing you the statements, but is she correct? Well, if I start to analyze this, well, there we go. Starting to analyze this, I can see that 3x minus 4i, well, that's one factor, and it is a complex factor. 7 minus 8i is another factor. It's a real factor. There's no I there. And then I have another 3x plus 4i, another factor, but it is a complex factor. Now, I'm noticing here, she probably thought that 3x, why can't I write over there? It's not letting me write at all on that. Oh, that's weird. Anyways, my apologies. She's probably thinking about that one factor of 3x minus 4i. Let's just go ahead and compare that with that other factor of 3x plus 4i. Very similar factors, but they are different. So these are 2 unique factors, which are indeed going to be giving us 2 unique solutions or 2 unique roots. If you wanted to be fancy, you could call these complex conjugates, because complex conjugates are only difference of plus and minus, but they are still different. So even though they are these are going to give us two complex roots. And then we have another factor of 7x minus 8, which is a real factor, there's no I, which is going to give us one real root. So she's right that there are three roots, but there are three unique, meaning different roots. And we know that there are three unique or three different roots because we have three different factors. That is actually the basis of all algebra. It is so important. It is called the fundamental theorem of algebra. Fundamental theorem of algebra says if you have three unique factors, you will have three unique roots. Well, actually, it says if degree n, you'll have n number of roots, but we can extrapolate from there. This would be a third degree polynomial if you kind of distributed or FOILed all of those three binomials out. You would get a third degree polynomial, which does match up with our three unique roots, two complex, one real root. So she's just misunderstanding that fundamental theorem of algebra here in number 4. Okay, so that is question 4. Question 5, there was a mistake in the proof of question number 2. So how would we fix that? How would we correct it? So rewrite the proof as a 2-column proof. Write your statements and reasons why. So I'm going to just solve that problem, showing you a 2-column proof. So on the left-hand side, I will do statements. On the right-hand side, I will give you the reason as to what. So step 1 is to tell you what the problem is, which was 9 plus 2i times 3 minus 5i minus 9 plus I times 3 minus 5i. Okay, so that's step 1, which is always the same. Tell me what I'm working with. Tell me your given. Okay, so now there are several different ways of solving this, none of which are more correct than the next. But I kind of liked the way that Princess Polly was talking. She recognized this common factor, so she factored that piece out. So if I pulled that piece out, step number 2 would look like 3 minus 5i. And that 3 minus 5i was multiplying with 9 plus 2i. And then we also had it multiplying with the subtraction of 9 plus I. So hopefully you can see that distributive property to get back to the original given statement in number 1. Well, what did we do to get question number 2? My favorite F word, we factored. Okay. So now looking at question number, step number 3 is I'm just going to simplify. I've done this before with you guys. That negative here is really a -1, so I just need to remember to distribute that guy. Did I sweep? I really want to make sure that I wrote down this question correctly. If you are like me, my mistakes are always because I wrote down the question incorrectly. So 9 plus I. Okay, I did write it down correctly. Okay. So we're going to simplify it. Minus 9 minus I, which that would be our distributive property. Number 4, I'm showing painstakingly every single step here. So I can see that 9 minus 9, oh, whatever, that's a 0. Don't need the 9 anymore. And then here I have positive 2i minus I. Okay, what did we do to get that answer of I? We simplified. You can also say something like combine like terms. Any of those would be fine. Number 5, well, I see multiplication here, so this I needs to be distributed. So to do that, I would get a 3i minus 5i squared. And again, that was our distributive property. Number 6, I am recognizing that there's an I squared. So remember, we committed to memory something about I squared. It is really a -1. So what did we do to get that -1? Our reasoning is that we substituted I squared equaling -1. All right, so now I'm just seeing some basic algebra there. Or really it's arithmetic, so I get 3i, -5 times a -1, positive I. Now you can say simplify over here, you can say multiply, something to just give me a reason of why there's all of a sudden a +5 there. Okay, and now looking here, these are not like terms. This is a complex number, so that's our final answer. So to put this into the courseware, you would just give me S1 and give me my statement here. Our S2, sorry, statement here. Reasoning R2 would be the factor. So typing that in would be totally great. Okay, moving on to the last question. Where did my 6 go? Oh, okay. Let me pause and I'll get it. Okay, and we're back. So question number 6 for this project is explain which theorem or theorems you use to check Princess Polly's work in question number 4. What does each of those theorems state exactly? So this is where I would really encourage you to go back and re-watch question number 4. I did use very specific vocabulary. I did tell you specifically about the theorems and what those theorems mean. So what you want to do is just rewatch it, make sure that you're understanding what those theorems mean and their application in that specific problem, and then rewrite it and describe it in your own words. Please remember that with every submission, you want to make sure that your grammar and punctuation is accurate. It's pretty painful to read if it's not. And as always, please reach out to me if you have any questions. Have a good day.